Hey y'all, so today we're going to discuss lesson 2-2, equations with variables on both sides. Before you start watching this video, I highly suggest that you go back and watch the Khan Academy videos that I have posted for you if you have not done so already. They will help you out tremendously. So if you've already done that, that's great. Excellent. So our learning targets for lesson 2-2 are we are going to write and solve an equation to model a real world situation, and we're going to interpret parts of an expression in terms of its context. Okay, so we're going to start dealing with real world situations with variables on both sides of equations. All right, scrolling down here. The Future Engineers of America Club, FEA, wants to raise money for a field trip to the Science Museum. The club members will hold an engineering contest to raise money. They are deciding between two different contests, the Straw Bridge contest and the Card Tower contest. The Straw Bridge contest will cost the club $5.50 per competitor plus $34.60 in extra expenses. The Card Tower contest will cost $4.25 per competitor plus $64.60 in extra expenses. To help decide which contest to host, club members want to determine how many competitors they would need for the cost of the two contests to be the same. So we're wanting to find out the cost of the Straw Bridge contest, the cost of the Card Tower contest, and see at what point do they equal. Okay, so looking at number one, write an equation that sets the cost of the two contests equal. So if I look over here on the left side, let me get back to my pen. If I look on the left side of this equation sign that you see written here, $5.50 times $34.60. Let's focus just on that side. If those numbers look familiar to you, that comes from Straw Bridge. The Straw Bridge contest will cost the club $5.50 per competitor plus $34.60 in extra expenses. So what that is it's $5.50 times X, where X is the number of competitors. X is the number of competitors. So $5.50 times the number of competitors plus the $34.60. $34.60 is your constant. It doesn't change. It's a flat rate. Hey, your expenses for this competition is going to be $34.60. Your variable is the $5.50 times X. That varies depending on how many competitors you have. So your variable X goes with $5.50. $34.60 is your constant. Never changes. Now I'm going to change pen colors here. Let's write in the pretty purple. Okay. $4.25 times X plus $64.60 comes right here. The Card Tower contest will cost $4.25 per competitor plus $64.60 in extra expenses. So I've got $4.25 times X. $4.25 is attached to your variable X because the number of competitor varies, and your $64.60 is your constant, never changes. You have a flat $64.60 in extra expenses. So if I go back to writing in red here. If I take my expression that I wrote for the straw, let me write straw here, and I set it equal to the expression that I wrote for the tower, this is the tower, that would be the equation that sets the cost of the two contests equal. Solve the equation that you just wrote in item 1 by using the algebraic method, showing each step, list a property of equality, or provide an explanation. Now I have room over here to the side of my paper. Whoops, I did not mean to move that. So I'm going to rewrite it over here for you. I'm going to write in red. Let me show you how I solve it. So we've got 550x plus, I might not have enough room to write this. Let me move this over a little bit. Try to get some extra room. I write kind of big. Let's see, what if I zoom in a little bit? Let's try this. What if I zoom in? Then I'll be able to write big on my screen, but it show it small for you. All right. Here we go. 550, if it would write for me now. There we go. 550. Let me fix this. Sorry, y'all. I'm getting there. 550x plus 3460 equals 425x plus 6460. Barely made it. All right, so I have no like terms on the left side of the equal and no like terms on the right side of the equal sign. So I'm going to focus on getting my terms with my variable x on one side and my constants on the right. So in order to do that, I'm going to first, you can start this in 4 different ways, but this is what I'm going to do. I'm going to subtract the $4.25 x from both sides. I'm going to try to keep everything positive. And when I do that, that gives me $1.25 x, because 550 minus 425 is 125, plus 3460 equals, those cancel, 6460. Now I want to move the 3460 to the right side by subtracting. I'm doing the inverse operation. Positive, negative right there. Minus 3460. Let me redo that so you can see it a little bit better. I'm not picking up my pen good enough, I suppose. Minus 3460. That looks better. Now I'm going to bring down my $1.25 x. Those cancel. Equals 6460 minus 3460. Leaves me with 30. Okay, now at this point, I want to isolate the variable x. And in order to isolate the variable x, I need to divide both sides by $1.25. The inverse operation of division is multiplication, or the inverse operation of multiplication is division. I'm sorry. So those cancel. And that leaves me with x equals 30 divided by 125, which is 24. So that is how you solve this multi-step equation. Okay, now let's go back down here. If you follow these steps in your book, I suggest writing what I wrote up there in the corner on the side of your paper over in that same area, like over here. But this is what your book has. You can pause the video here and write all of this down and see if you can follow step by step. But what I did up above is very similar. The only difference is that they got rid of the decimals. And you can do that, but it's not necessary. If you don't like dealing with decimals, you can multiply each term by 100 and it would eliminate your decimals. That's what they did from here to here. They multiplied each term by 100, and you can very well do that to eliminate the decimals and then follow the steps that I did. There's several different ways that you can go about solving this equation, but as long as you end up with x equals 24 at the very end after you do all your operations, as long as you end up with x equals 24, you're fine. Okay, so if you did a different method but ended up with x equals 24, perfect. You are not wrong. Interpret the meaning of the value of x in the context of the problem. So if you look at the problem, what did x stand for? What did x represent in our real world situation? X represented the number of competitors. Okay, x represented the number of competitors. So the solution x equals 24 represents the number of competitors that would make the cost of hosting the straw bridge contest the same as the cost of hosting the card tower contest. So if they had 24 competitors, the cost of the contest will end up being the same as long as they had 24. The FEA Club estimates that I'm on number 4. The FEA Club estimates they will have more than 30 competitors in their contest. Make a recommendation to the club explaining which contest would be the better choice and why. So your recommendations could vary as far as the reasoning, but everyone should be recommending that the card tower contest is the better choice. And the reason being is that if you look at the explanation here, choose a value greater than 30. So you may choose any value greater than 30. Say there was 31 competitors, or you can take the easy road and do an even number 50 or 100 even. A lot of people like to substitute in the value of 100 because it's easy. Substitute it into the cost expression for each company. For 35 competitors, they increased to 35. The Strawbridge contest cost, if you see your equation there, $5.50 times 35 competitors plus the $34.60 fixed cost ends up being $227.10. For 35 competitors of the card tower contest, and if you substitute in 35 into the equation, you get $213.35. So the cost to the club will be less for the card tower. So if the cost is less, their income would be more. So they want to recommend the card tower because the cost of having the competition for the card tower contest is cost less, their income would be more. Okay, number 5, the FEA Club will charge each competitor $10 to enter the engineering contest. Write an expression for the club's revenue if X competitors enter the contest. Well, it's going to be $10 times however many competitors you have. That would be the entrance fee. $10 for each competitor, where X represents the number of competitors, so it's 10X. Number 6, part A, write an equation to find the break-even point for the fundraiser using the contest you recommended. So I'm going to say, okay, in order to put on the contest, it's $4.25 times the number of competitors plus $64.60. That's the expression that represents the cost of the card tower competition. So if that represents the cost to perform the competition, and I set it equal to the expression 10x, which represents their revenue because they're charging $10 for each competitor to enter, if I set those two expressions equal to each other, that would give me my break-even point. That would give me my break-even point. Okay? Break-even means that you don't make a profit. You earn what you spent. So 10x is their earnings, $4.25 times x plus $64.60 is their cost. So when you have the earnings set equal to the cost, your revenue set equal to the cost, that's your break-even point. And this block over here explains what I just said as well in a different way. Part B, solve the equation that you wrote in Part A. State a property of each equality or provide an explanation for each step and how many competitors does the club need to break even. So if you solve that equation that we wrote in Part A, it will give you how many competitors you need in order to break even. And here are all the steps that you see below. Again, they multiplied each term by 100 to eliminate the decimal. You do not have to do that. Follow the steps to solve that equation, and you should get X is approximately 11.23. So what does X represent? X represents the number of competitors, the number of people. Can you have a 0.23 portion of a person? No, I hope not. You have to count people in whole numbers. You can't have a part of a person. So there cannot be 11.23 competitors, so round up to 12. You do not round down in this case. If I were to say round 11.23, you would round to 11. But in this case, you don't want to round down because then your revenue will not be, your revenue would not be the same as your cost. Okay, so in order to break even, they're going to have 12 competitors. So their profit is ended up going to be a little bit more than their revenue. Or their revenue is going to be a little bit more than their cost. I'm sorry. Revenue and profit, same thing. All right. Let's see here. All right, number 7. How much profit will the FEA club earn from 32 competitors if they use the contest that you recommended? So their revenue here, that's what the capital R stands for, okay? The revenue minus the cost is your profit. What you make minus how much it costs you to have that competition would be the profit, how much you actually earn, okay? So my revenue is 10 times 32. 10 times 32, that's the entrance fee. $10 per competitor for 32 competitors, $320. So they earned $320. They brought in $320 from the competition. However, their cost, you have to subtract your cost out. How much did it cost you to put on that competition for 32 competitors? That's where the C is. So the revenue is how much they earned in ticket sales. Okay, this is their ticket sales. Their cost is the expression that we wrote, the $4.25 per competitor plus the $64.60 fixed cost is $260. When you substitute in $32, you get $200.60. Now their profit, okay, their profit is the revenue minus cost, the $320 minus the $200.60 that it costs to perform. So their profit ends up being $119.40. All right, last question, number 8. The Future Engineers of America Club treasurer was going back through the fundraising records. On Monday, the club made revenue of $140 selling contest tickets at $10 each. One person sold 8 tickets, but the other person selling that day forgot to write down how many tickets that she sold. This is a real world situation. There's 2 different booths. One person sold 8 tickets. The other person said, oh, I forgot to write down how many I sold, but they know that together they made a revenue of $140. So let's try to figure out how I can write an equation to figure out how much the other person sold. Okay, so $10 times 8 plus x equals 140 is the equation that you want to write. Okay, so $10 represents the cost of each ticket. $10 is the cost of each ticket. Cost of ticket. So $10 times how many tickets equals 140. 140 came from their total revenue. Okay, that came from right here. Total revenue. This is where the 10 came from, $10 each. So 140 is their revenue. So if they know that 10 times however many tickets they sold was 140, and they know that one person sold 8, well, you need to figure out 8 plus what? 8 plus what? The X represents the number of tickets that the other person sold. 8 tickets that I sold plus how many tickets did you sell times 10 equals 140. When you solve that, you end up getting X equals 6. X equals 6. So 10 times 8 plus X. Now you can also solve this by saying, well, if I know that person 1 sold 8 tickets at $10 each, that's $80. Person 1 made $80. And then person 2, they would have had to make something else. And together they earned $140. So I know person 1 made $80. Person 2 made something to earn $140. And then you subtract that out. And you get X equals 60. Does that mean that person 2 sold 60 tickets? No, not 60 tickets. They made $60. So in this case, X represents the number of dollars, not the number of tickets. So if I know that tickets were $10, that means that person 2 sold $60 divided by $10. So person 2 sold 6 tickets. 60 divided by 10 is 6. That's another way that you could have solved this, which is perfectly fine. But in this case, you would have written X as being 8 minus x, which is essentially the same as this equation. Both are correct, though. Okay, so now I want you to check your understanding number 9 and 10 as classwork and turn that in. And lesson 2-2 practice, numbers 11 through 15, and turn that in for homework.